Hello, my name is Valerie Moron,
Hello, my name is Manuel Castellanos.
and this is our project on thermochemistry. So what is thermochemistry? Thermochemistry is the branch of chemistry that relates to heat with chemical reaction or physical change of state. In some situations, the energy produced by chemical reactions of it's actually of greater interest to chemists than the material produced of the reaction. For example, the controlled combustion of organic molecules, primary sugars or fats in our bodies, provide energy for physical activity throughout other complex and chemical transformations that occur in our bodies.
Okay, so first of all, we have to understand that thermochemistry and thermodynamics are not the same thing. So thermodynamics is the overall study of heat conversions and other energy forms, while thermochemistry is especially the study of thermodynamics in regards to chemical reactions. Next, please. Okay, so next we have some thermochemistry history. So the thermochemistry rests on two generalizations. The first one is Lavoisier and Laplace law, 1780. The energy change in any transformation is equal and opposite to the energy change in the reverse process. And the second one is Hess law, 1840. The energy change in any transformation is the same whether the process occurs in one step or many. Okay, so we have three different types of heat transfer. So the first one is conduction. When heat is transferred, the substance itself does not flow. Rather, heat is transferred internally by vibrations of atoms and molecules. The second one is convection. The transfer of heat or from a fluid medium. Molecules in gas or liquid in contact with a solid body transmit or absorb heat to or from that body and then move away, allowing other molecules to move into place and repeat the process. The number three is radiation. Is the emission of electromagnetic waves from all matter that has a temperature greater than absolute zero. Thermal radiation reflects the conversion of thermal energy into electromagnetic energy, as we can see in the image below.
So there's also two types of energy exchanges. One of them is work. Work involves an energy transfer resulting from the movement of an object. And the second one is heat, and is the amount of energy that's transferred from one system to its surrounding because of the temperature differences. So as you see in the images, there's the difference between work and heat. So yeah. So important facts. One of the important facts is that in this field, this is also like Manuel mentioned, this is one of the fields of thermodynamics. It's different. But one of the important fields of thermodynamics is heat transfer as well as thermochemistry. It relates to the transfer of heat between two media. Thermodynamics also involves the study of various types of power plants, like thermal power plants, nuclear power plants, hydroelectric power plants, and lots of more. Or also like renewable sources, energy sources like solar, wind, geothermal, tides, and water waves. Also, renewable energy is an important subject area of thermodynamics and chemistry, since it involves the studying of flexibility of using different types of renewable energy sources for domestic and commercial uses.
Okay, so the thermochemistry in life. So we can see this in all type of transportation, such as cars, motorcycles, trucks, ships, airplanes, and more relate to the second law of thermodynamics. They might use petrol engine or diesel engine, but the law remains the same. So what does that mean? It doesn't matter if the car is like, for example, electric or like a regular car.
Yeah.
It's the same thing, right? It's the law remains the same. So another example of transportation include melting when a solid becomes a liquid, and boiling when a liquid becomes a gas. A reaction gives out or takes in energy, same as a physical transformation.
You want me to go next slide?
Yeah, yes, please. Okay, so here we can clearly see the tools used in thermochemistry. We have the thermometer, the beaker, liquid, reaction mixture, the polystyrene cup, and the cotton wool distillation. Yeah, that's it.
Oh, also, a calometer is used in measuring thermal energy transfer in a chemical reaction, such as heat and stuff. So for conclusion, thermochemistry is very important in the field of science, such as chemistry, physics, biology, any type of science, because it helps determine if a particular reaction will occur and if it will release or absorb energy as it occurs. Also, it's possible to calculate how much energy every reaction will release or absorb in an object, and this information can be used to determine if it's economically like good to use, or we should use another particular chemical in the chemical process.
Mm.
So yeah, that concludes our presentation. Thank you very much.